Hey guys, welcome back. This is episode 6 in my tutorial series on how to make a 2D game in Android Studio. And in this episode we're going to be covering animations and texture drawing, which I'm really just going to be covering animations because for texture drawing, if you want to do just a static image, you should be able to do that with what you learn through animations, and if not, you could always make an animation with one frame. So anyways, to get into this, we're going to do a bit of a modification to our constants class. We're going to add one line which will come and become useful later on. So we're going to say public static context, and we're going to name it current context. And then what we're going to go do is go over to your game panel class. And in the constructor, right after this get holder add callback line, say constants dot current context equals context, and that's good. We can leave it at that. Now what we're gonna do is make an animation class and hit OK. And these animation class will essentially just play an animation, so we can have multiple animations attached to a game object. So what we really need here is we need a bitmap array, which bitmaps are basically images, so I'll call this frames. We need an int that is our frame index. We need a boolean called isPlaying to know whether it's playing, and by default it's going to be false. And then I'm going to have a kind of like a get method, but it's just going to be isPlaying but as a method, and it's just going to return isPlaying. And then we're going to have a public void play, and that's going to set isPlaying to true. My bad, we want the actual variable, not the method. And then we're also going to have a void that is called stop, and that of course sets isPlaying to false. And now we also need a float, which is going to be frame time, and so that works. And now what we're going to do, and frame time is just going to be the time in between frames. And now we need a constructor, so I'll do public animation, and it's going to take in a bitmap array for frames, and it's going to take in a float, and that's going to be animation time, or its speed basically. And then we're going to say this dot frames is equal to frames, so we're going to assign the instance variable the argument, and then we're going to say frame index equals 0, and we're going to say frame time is going to be equal to the total animation time divided by the number of frames. So we're going to evenly space the time in between frames. Great, and now we actually need another thing, and that's going to be a private long, and it's going to be called last frame. So last frame is going to be equal to system.currentTimeMillis, and then we're going to come down here and we're going to make our public void update, and in here we're going to do a few things. We're going to say if system.currentTimeMillis minus last frame is greater than frame time times 1,000, because I'm gonna put the animation time in seconds, hence frame time will be in seconds, and so we need to multiply it by 1,000 so that we're comparing milliseconds to milliseconds. So if the amount of time has passed for us to need to change the frame, we're gonna say frame index plus plus go to the next frame, and we're gonna say if frame index, I'm actually going to put it in one line, so this is called, I believe, a ternary statement, and it's going to be basically frame index equals, and I'm going to say frame index greater or equal to frames dot length. So if we've already exceeded the highest index, then we want to say it's equal to 0. Otherwise, we just keep it at frame index. So basically what this does is we provide basically an if statement, and we put a question mark basically asking if it's true. And if it is true, then we want to set frame index equal to this. And then we do a colon to say if it's not true, then we set to whatever's on the other side of the colon, which is we just keep it the same. Great, so that saves us a line of code. And now what we want to say is last frame equals system dot current time millis. That's good. And I believe that takes care of that. We'll see. And now we want to also add a statement that's just going to say if we're not playing, then we just want to return. We don't even want to go through this whole update method. And now what we're going to do is a public, and let's see here, public void draw. We're going to take in a canvas, and we're also going to take in something a little new here. We're going to take in a rect, and we'll call it destination. So go ahead and import that, and let me explain why we're doing this. We're going to need to draw these bitmaps to screen, and if you take a look over here at the Android documentation, if I can scroll down and find it, we have this method right here. Draw bitmap, and it takes in the image, the bitmap, and it takes in a source rectangle, which is basically what portion of the provided bitmap do we want to draw. And then we also have a destination rectangle, and it'll basically draw the image to fill that rectangle. So it'll match where that rectangle is on the screen and fill the entire rectangle with the image. So it'll scale it and translate the image to match it. And then the paint's just for extra drawing styles. So we're going to be using this method. And of course what we want to do here in a draw method is say if we're not playing, then we just want to return, because it would be kind of pointless to draw it even though we're not playing the method. So then what we're going to do is say, let's see here, we're going to do canvas.draw bitmap, and we're going to draw our frame at frame index. And then we're going to do our source rectangle, which is going to be null because we want to draw the entire image. And then we're going to pass destination and a new paint. Import that, and we should be good. One last thing I'm going to add to the stop method is I'm going to say, let me delete this import. But I'm going to say frame index equals 0. We're going to restart back to the frame index. Or actually, guys, instead of on stop, I'm going to do that on play. And also on play, what we want to do is say last frame equals system.current time millis. We're going to restart that kind of counter. And that should be good. Now, we can actually implement these animations. So come over here into Rect Player, and we're going to add a few animations. We're going to say, let me make them private, but we're going to do a private animation, and it's going to be called idle. And the next one's going to be walk right. And the final one's going to be walk left. Perfect. Save that. And now we actually need some images that we're going to be drawing. I believe I already have them imported, but if you go to resources and drawable, you'll see I have some images. I'll show you where I got them from. Basically, open your web browser and go to opengameart.org. And this is a great site for getting game resources. A lot of them are in public domain, or at least let you use them if you provide attribution. So definitely check this site out. But what we're going to do is search Kine. And Kine's actually their own company, so you can also check out their site. They have a lot of cool stuff, and I recommend doing that. But we're just going to click on platform or art, more animation and enemies. And what you're going to do is just click this zip download link and download that and extract it, and you'll have the resources. I'll provide a link in the description to this site, or to this page. And anyways, I already have that downloaded and I have it open as well. If you go into the alien sprites folder, you'll see we have a bunch of characters. We can probably set up a character shop later, but for now I chose to use just the blue alien. And what you have to do is, you can't drag and drop these images in, so what you have to do is select the ones you want. I chose to get walk 1, walk 2, and the just kind of idle animation for it. And what you're going to want to do is just hit Control C, and then come over here and click your drawable folder and Control V, and it should be pasted in there. Alright. So now what we're going to want to do is actually create these animations here, and we'll do that in this constructor. So we're going to say we need to do a few things. So we need a bitmap factory, just call it VF, make it a new bitmap factory. This is basically for decoding, producing, modifying bitmaps, all sorts of things. And now what we're going to want to say is bitmap idle, and it's going to be equal to bf.decode resource. And now here's where we use our constants. So constants.currentContext.getResources, comma, and then we're going to do r.drawable.alienBlue, since alien blues are idle frame. Oh, and also one thing I noticed when I was creating this, what you have to do is when you import these images, notice how they have a capital B here. What you're going to want to do is, I recommend doing it before you even paste it in, but you can also do it in here. You have to change this capital B to a lowercase b, otherwise you get an error because it's not a loud character. So make sure you get that done. And anyways, we have our idle frame now, and it kind of shows it off to the side there. And now we're going to get the other bitmap, so it's going to be walk 1, and it's going to be equal to bf.decode resource. And I'm actually just going to copy this line and kind of just change it a bit because it's essentially the same line. And instead of alien blue, we're going to do underscore walk 1. Okay, bitmap walk 2, and paste that, and it's going to be alien blue underscore walk 2. Perfect. So now we can create some of the animations. Notice by default the alien's walking to the right, so we can only create walk right at this point. But what we're going to do is say idle, and actually let me change this because the animation's name is idle too. I'll just do idle image. So we're going to say idle equals a new animation, and it's going to be a new bitmap array containing idle, just a single frame. And since it's a single frame, we can just say any amount of time will do. And I meant to do idle image. So any amount of time will do because it doesn't matter when it switches, because it's just going to switch back to the same frame. So we're going to come here and we're going to say now for walk right, we're going to say is a new animation, new bitmap array, and it's going to take in walk 1 and walk 2 as its frames, and I'm going to say it takes half a second to do, and make sure you put an F there because we use floats, not doubles. And now we can do walk left, but we have to do a little bit of work with these because the characters need to be facing the left, not the right, so we kind of need to reflect them on the vertical axis. For that, what you're going to want to do is come over here. I'll provide a link to this. There's a Stack Overflow post. I've already talked about this site before, but there's a good entry that we can use, so just go ahead and copy these. Alright, paste it, and now we're going to do some modification. So we can delete this line, and what we're going to want to do is, instead of SRC, do walk 1, and walk 1, and just rename this to walk 1 left, or actually just name it walk 1, just set walk 1 to this. And also this matrix that we're using to create the bitmap, it's basically right here is where we set it to where the x coordinates get flipped, so that's kind of what does this flipping on the vertical axis. That's what we want. And now we're also going to set walk 2 to this, and just replace these 1s with 2s. So now we've reassigned walk 1 and walk 2 to their kind of reflected versions. And so we're going to copy this line right here for walk right and set walk left now to the same thing using walk 1 and walk 2, because now we've all altered them to face the other way. So that works. And now we have our animations completed. Now what we want to do is in this update method, we want to actually figure out if which direction the player is moving, if at all, and play that animation. So what I'm going to do for this is I'm going to store I believe it's going to be a float. That's what I'm going to store it as. And it's going to be called old left, and it's going to be equal to rectangle.left. So it's going to be the left x coordinate of our rectangle before we modify it. So it's going to then we can compare it to what it is after the modification to see whether it's further to the right, further to the left, or basically didn't move. And that's how we'll assess it. So then what we're going to do is we're going to say int state, and it's going to be equal to 0 by default. State will basically be 0 will represent idle, 1 will represent walking to the right, and 2 will be walking to the left. So then what we're going to do is say if old left minus rectangle dot left is greater than 5. Okay, wait, no, I want to reverse this so I can kind of think. We're going to do rectangle dot left minus old left. So the new minus old is greater than 5. And notice I could say greater than 0, but that would be very kind of rough, because that would mean they only have to move a fraction of a pixel, which that doesn't leave much like room to cut out error, so there'll be a lot of kind of just glitching around. So I'm going to say it has to move at least 5 pixels for us to recognize it. And so basically we're going to say if the new left minus the old left is greater than 5 pixels, so it moved to the right, then our player is moving to the right, and our state should be equal to 1. And else if rectangle dot left minus old left is greater than or less than -5, so that it moved, the difference is greater than 5 pixels in the left direction, then we're going to say we're moving to the left, so our state is equal to 2. So now that we've collected our states and we have information about what animation should be playing, it's actually going to be good to have an animation manager at this point. So go ahead and create a Java class, and it'll be called Animation Manager. Go ahead and paste that there. And what we're going to do is, take in in its constructor, public animation manager, it's going to take in an animation array, and it's just going to be animations. And we're going to store those, so we're going to have a private animations, and let's see here, that's obviously not right, private animation array animations, and we're going to set that right here. And then we're going to do a similar thing here. We're going to have a animation index. That's going to be an integer, so animation index, and it's going to start out at 0. And then what we're going to do is have a method called, it's going to be a void, and it's going to be called play anim, and it's going to be int index. And then we're going to send in, or what we're going to do is we're going to say for int I equals 0, we're going to do a for loop. I less than animations dot length I plus plus. And what we're going to say is if I equals, actually we can do no, okay, so we're going to say if I equals index, then what we're going to do is say animations at I dot play. Otherwise, we're going to say animations at I dot stop. Okay, so we're going to play that one and stop all the others. Great. And now what we're going to do is come over here to animation and basically okay, so we need a draw and an update method. So what we're going to do is come over here to animation manager, and we're also going to, actually I forget one thing, we're going to set animation index, so the one we're on, to this index. And so now what we're going to come down here and do though is have a public draw method. It's going to take in a canvas and a rect, just like our animation draw method has. And then we're going to just do animations at animation index dot draw, and we're going to pass in canvas and rect. And then we're going to say for our update method, and one thing we should also check just in case, we're going to say if animations at animation index dot is playing. So if it is playing, then we're going to go ahead and do it. I forgot to add void on both of these, so fix that. And then we're going to do a similar thing here, copy this and just change this to update. Perfect, save that. That is good now. So now we're going to come back into our rect player and we're going to create an animation manager. We'll just call it anim manager or animation manager. I'm actually going to shorten it to anim manager, and then what we're going to do is say anim manager equals a new animation manager, and it's going to take in a new animation array, which is going to have idle. And remember how we did the states. Let's see here, we had 0 is idle, so we want to put idle at the 0 index. 1 is right, so walk right is going to be index 1 in our animation manager, and walk left is going to be our final index, index 2 in our animation manager. Save that, and then we're just going to say anim manager dot, and then we're going to say play anim index, let's see here, state. And one thing we also want to do in our animation manager is come over here, and when we say to play the animation, remember that our play method resets it back to frame 1. So we want to say if it's not already playing. So we're going to say if animations at index is not playing, then we're going to play it. Okay, save that. That should be good to go. And now we just got to add some lines into our draw and update. So our update method is going to just be animManager.update, and we're also going to call that here, since this is kind of a second update method in this. And now what we want to do is add to our draw method. So let's we can comment out this because now we're drawing animations, not a rectangle. And what we're going to do is animManager.draw, and we're going to pass in a canvas and a rectangle, I believe. So we're going to do rectangle. And now we're pretty much good, except for this destination rectangle. Notice that it can be any rectangle, and the image is going to scale to fit it, and we don't want it to be distorted when that happens. So we want the width to height ratio of this rectangle to match that of the image. So we're going to go ahead and modify the rectangle to meet that criteria up here in the constructor. So go ahead and create a float, and it's going to be width height ratio, and it's going to be equal to I'll do idle dot, actually guys, I'm going to add that in our actual animation, because I believe that the animation should all kind of scale to the proper size. I don't think we ever would really want them stretched, so I'm going to actually have that be standard for all animations. So let's see here. When we draw our animation, what we're going to do is say, so this destination rectangle, we're going to say, and create a method to scale it. So scale rect, and it's going to be destination. We're going to create this method, and it's going to be a private void scale rect. It's going to take in a rect. And now what we're going to do is say float width height ratio is going to be equal to frames at frame index dot get width, and I'm going to typecast this to float so that we're not doing integer division here, and I'm going to divide it by, copy this, I'm going to divide it by the height. Great, so now we have the width height ratio, and what we're going to do is I'm going to scale the smallest, let's see here, I'll scale the largest dimension on the rectangle to match this width height ratio, so that will always be at least contained inside the rectangle. We may be smaller than it so that the image width height ratio is met, but it will always be contained in that rectangle, which is good. So I'm going to say if rect dot, and then we'll say width is greater than its height. So if width is the largest one, then we're going to say rect dot, let's see here, top is going to be equal to, and then we're going to say rect dot bottom minus, and then we're going to subtract off how high it should be, and so we're going to do rect dot height times width height ratio. And I got to typecast this to, I believe, an integer. Alright, that works. And I don't need brackets, this is one line. And now I'm going to say else, copy this, and I'm going to say that the right is equal, or no, I'll say the left is equal to the right minus how wide it should be, and that will be wait, let's see here. Okay, so here we're sorry, excuse me guys. This should be modifying the width. This should be modifying the height. So we're going to change, I'm going to switch this around. This is going to be left, and it's equal to right minus, and this is going to be top, and it's going to be equal to the bottom minus this. And this is going to be width times 1 divided by width height ratio. Perfect. And that should be all the scaling we need, so that when we actually draw it, there's no stretching of the image. And now I believe if we go ahead and play this, it should be working. So let's give it a run. Alright guys, so here we are. App's opened up. And here we are with our idle character, and now we walk to the sides when we go that way. and that's exactly what we wanted. And if we stay still, it does nothing. And I think that'll wrap it up for this video then. In the next video, I may be covering gyroscope controls. I saw a comment requesting that. But whatever it is, thanks for watching, and stay tuned for the next video.